Hello everyone, Swagatam and very warm welcome to all of you at this amazing platform PW. My name is Aman, your favorite maths buddy. I hope you guys remember me. We have been doing revisions of all the chapters of mathematics of grade 10. So it's been a long time now. There was a hiatus in between, there was a gap in between. So in that gap, I believe you have continued well with your preparation of this important grade of class 10th. And you are now very close or nearer to your examination, pre-boards or mock tests. Going forward, you have to assess yourself how well you are doing. In that same series, I'm coming up over here with the next chapter in the series, which is surface area and volume. Surface area and volume. What I have to say about this chapter? There are two things about this. One being good, another being not so good. What's the good part about it? The good part is in this particular chapter, you are not going to learn anything new. So why are we learning this chapter in the first place? We are learning this chapter because there is a slight modification in whatever you have learned. What I have learned, sir? We have learned few basic formulas of some solid bodies basically, 3D figures basically. Now, what are these 3D figures we are talking about? We are talking about 3D figures like cube, cuboid, cylinder, cone and all these things. So we'll be talking about once again about these things, and since we have talked about in previous grade about all these things, so that is why I'm saying there is nothing new in this particular grade, in this particular chapter. And what's the bad part, sir? The bad part about it is this is a very formula oriented chapter. When I say formula oriented, so many people enjoy the thing that we are having a formula, just apply the values, get the answer, and the things are done very easily. And few smart students like it to be very boring, find it to be very boring, to be very honest, because there is no new thing coming up, no creativity as such in the problem statement. Things are very obvious and we have to repeat the same process, just like statistic. I say the same thing about statistic as well. When the things are very formula oriented, when the things are very monotonous or mundane, things sometimes get boring for very smart student. So you have to escape that loop out of this part and make sure that you are engaging in the calculation with full intent and full involvement over there. If you are feeling that you are not connected with the problem, you will be having some issues with the calculation. So on that note, without wasting any more time, let's start the session, quickly wrap it up. So before starting, I would have to give you some hint about what we have learned till now. So we'll do a quick revision of that also, and for that we'll be starting with the difference between what 2D figures and what 3D figures are. So for the 3D figures, since I've clearly mentioned in this particular chapter, we are now dealing with 3D figures. We have already dealt with 2D figures. What kind of 2D figures? Now if I ask you to calculate the area of a circle, of a triangle or a square or a rectangle, I believe things will be quite easy for you. It's like I'm asking something from grade 6th or 7th, right? Yeah, and that's the case exactly. But things have changed a bit. Now we are dealing with solid bodies. When we say solid bodies, what kind of a bodies are we talking about? We are talking about bodies like cricket ball. So cricket ball is something you're having in your hand. But on the contrary, if I just create a circle over here, if I just create a circle over here, it feels like a simple 2D thing on the surface. You would be asking me for the radius, you'll be asking that, okay, this is the radius, so I can calculate the area of it by pi r square. Things are that simple. But in the case of when we are talking about a solid body, things will be some difference. Yeah, over here we are having a third dimension. So when we talk about a simple square, so square is a 2D thing where no difference is there. It's everything on the piece of paper. So if we talk about the side of it, let's say this is A, this will also be A. But when we talk about a 3D thing, there will be other than the length and the breadth something more. So one more dimension is being added. So in your school, they must have been talking about the part that add more dimensions to your personality. When they say add more dimension to personality, add some new aspect to it. So over here, length is there, breadth is there. So add some height to it. So when you have talking about height in this particular scenario, so over there we are talking about the depth of it. So you must have seen movies in the 3D theater, 3D movies coming up. Let's say, I don't know if you have seen the superhero Marvel movies like Avengers and all, they would have appeared in the 3D screen. So over there will be a depth perception which you would be having. So depth perception is what? The third dimension we are talking about, because otherwise you were already seeing on the screen over there which was having a length and breadth. And that exactly what 3D thinks. So 3D simply is three-dimensional. We are talking about the third dimension over here. So third dimension, if we talk about, let's say a cuboid, we'll be having a length, we'll be having a breadth, we are having the third dimension which we are terming in terms of height. So these are the three dimensions we are talking about. So if I have drawn these 2D bodies in front of your screen, so if I talk about the 3D figure, it will be what? Cube, cuboid, cone, cylinder, sphere, all these things, and these are the things we are talking about in this particular session. So let's start with the first and the most basic, that is cuboid. So when we are talking about cuboid, here we are talking about cuboid. So first of all, let's understand how to draw it on the piece of paper, because as I mentioned, on the piece of paper, whatever we are drawing, it appears to be a 2D thing. But no, over here we are talking about a 3D thing. So over here there should be some perception of depth. And how do we create it? So here we have some kind of a drawing involved. So this is a rectangle which we generally consider. In this rectangle, if I have to give a depth, so this is the manner I am providing it a depth. So now it appears like it is having another face, and same I'll be doing for the rest of the faces, joining this, these two and these two. Now it seems like a body, which is a 3D thing, and even if you don't know whether this is a 3D thing or not, in the upcoming time, you will be coming across many such bodies, and yeah, this is the way you will be representing a 3D thing on a piece of paper, which is a 2D thing. So this is what a representation of a cuboid. Many of you might be confused, sir, it seems like a cube. You don't know whether the length and the breadth and the height all are same. It appears to you, that's your perception of things. So perception can be different from the reality. So you have to avoid that own perception. So if I talk about the cuboid, and when we are talking about any solid thing, so there are two things we should be interested in. The first thing is the surface area, and the second thing is volume. In the surface area also we are having two things. What are these two things? The first thing is the lateral surface area and the total surface area. Now let's talk about the total surface area first, which we represent by TSA. Interesting how we get this total surface area. You must have come across, like if we are talking about a cuboid, it is having multiple faces. Okay, so front face, back face, side face, another side, top and the bottom. So in total, how many I have talked about? 1, 2, 3, 4, 5, 6. In total, 6 faces I have talked about. So if I talk about the, let's say the front face, this is having some length and this is having some breadth, length and breadth. So when we talk about the total surface area, this will be 2 times of length and breadth. So why this 2 times? So if you're talking about the front face of it, definitely you should be talking about the back face of it. If something is having a front face, it will be having a back face, right? So if you're having a book at the moment, if you're having a textbook which is in the shape of cuboid, so you will be having a front face of it which will be colorful, and you'll be having a back face where it will be written how much cost it is. So right, so front face and the back face, that is by 2 into length into breadth. Same thing I'll be doing with the other faces, but over here is the difference. Over here it was length and breadth. Every time it will not be same. At the point it was length and breadth. For other face it will be what? It might be breadth and the height. It might be breadth and the height, anything. So I'll be writing over here twice of breadth into height. This is for other face, which will be having 2 sides. 2 sides means opposite front of it. And same for the third face, which will be having again 2 things, front and the back side of it. So 2 into H into L. In this form, it appears the total surface area as 2 into LB plus BH plus HL. The total surface area of a cuboid. A total surface area of a cuboid. This is the way you need to understand it, and this is the way it is being applied by putting up the value of length, breadth and height, all 3 in this particular formula. The total surface area done, and then sir, what's the difference between the lateral one? So over here we use the term lateral, which simply represent the 4 faces. So when you are sitting in a classroom or you are sitting in a particular home room setting, over there you are inside a box. You can assume it to be a box. If you have that imagination, it's good. Otherwise, if you are understanding what kind of a box I'm talking about, you can think about what? You can think about a matchbox. So matchsticks are inside a box. So if you put yourself in that particular place and observe the particular place like this in a 3D setting, you'll observe there will be 4 faces. 1, 2, 3. So I've already shown you 3, and back will be a 4th face. But apart from that, there'll be a top face and there'll be a bottom face. I don't want to consider the top and the bottom. Understand, in this manner, I want to paint my room. For painting, I'll not be painting on the floor. This is for sure. And about the ceiling, my parents have decided they want to put a false ceiling. They have decorated it, whatever they want to do it. They have put up a false ceiling and they don't want to paint it. So what are left for painting? We have only 4 walls which needs to be painted: the front, the back one, the 2 side walls. So 4 walls we are talking about. We are talking about the lateral surface area, and the lateral surface area is easy to find. If you talk about the bottom face, if I want to calculate the perimeter of it, what is the perimeter? I hope these are the 2D things which you have remembered from the previous grades. So it is 2 into L plus B. If I simply multiply height, why? Because this surface I provide simply the height. I would be having the entire area for this particular 4 walls. So that is how it comes 2 into L plus B, and H is being multiplied over here. This is the lateral surface area. These are two surface area which we'll be talking about. And other than the surface area, what is the next thing? The next thing is volume. And volume, don't worry, a single volume would be there. There will not be multiple volumes involved. Any of the body we are going to talk about. Over here, the volume is simple to understand. If we are having 2 faces, so L into B. If we are having the third face, if we are having the third dimensions to it, so length into breadth into height is what we are going to do. So it's easy to understand the volume in this case will be length into breadth into height, and that will be our volume. The 3 formulas are involved in the case of cuboid, and that is how we wrap up the cuboid part. Cuboid was easy to understand, and I believe just by assuming that you are sitting inside a matchbox, which is very easy to understand, like a prison hole you are sitting at the moment and you want to fly out of it. So you should have understanding about the dimensions of how big the room is and where should we get the ventilation out. Now, in this case, we are going to talk about the next thing, which is a basic relation between with the cuboid part. If I say the length, the breadth and the height, all 3 become same. All 3 become same, and that is I was talking about how big the room you are talking about. If all 3 become same, length, breadth and height, so in that case we are talking about a cube. So for the cube, things are very simple. I'll not talk about any new thing, and I'll not do the construction also, because the last figure I believe you would have assumed to be cube. So in this case, the surface area. So the lateral surface area, first of all, let me talk about. We talk about only 4 faces of it. So 4 faces, for one face we are having the area of A square. So 4 faces, 4A square. If we talk about the total surface area, we are now going to talk about, or I will be involving the ceiling as well as the floor. So 2 more added to it, 4 plus 2 is 6. So 6A square. The volume of that particular cube, it was length into breadth into height. I told you L is equals to B is equals to H is equals to, let's say, A. So let me write it down over here. In this case, we are having the volume to be A cube, and that is all the 3 formulas we have for the case of cube as well. So cube is basic relation, is in relation with the cuboid part, and easy for the conversion part. So you can think of a cubical box, you can think of a Rubik cube, or whatever kind of a body you can assume. So this was for the cube. Now let's move into the section where rather than having only the straight lines, we are having some form of curves. So when we talk about the curve, the first thing comes to my mind is the cylindrical bodies, For the cylinder, things are easy to start with. Why, sir? So let's say we are having a circle. If we are having a circle, now if I start putting more circles above it, or you can assume, let's take a bangle, which is a better representation of circle. So if you start putting multiple bangles, it will form a shape like this. This will be a kind of a shape coming, and if you are having any sort of confusion, this will be one bangle, and above it I'll be putting up more bangle like this. I'm trying my very best, level very best, so that you have a clear assumption what I'm trying to do over here. These are different bangles appearing in the form of making up basically a cylinder. Ultimately, it was one circle at the bottom, and above which we have accumulated multiple circles like this, and we have come up with a body which is like a cylinder. Why I have taken this example? So that you have the ease to understand the formula itself. I don't know now it appears to be like a circle or not. You can think of bangles, or if you're not able to assume bangles, it seems like a feminine thing. So we can think of tires basically. So multiple tires being racked up one above another. So you'll be coming up with a cylinder over here. So this is a cylinder. So in this case, we are having 2 kinds of surface area. The first we talk about is the curved surface area. Sir, in the previous case, we were talking about lateral. Why the word curved appeared over here? The word curved appeared over here because if you understand, not assume, these things, the tires which we are talking about. So tire is basically what? A circular shape. So entire body that coming up will be what? A curved body. So in this case, there will be no 4 walls. There will be the curved part of it, and that is why we are talking about the curved surface area. Now, we are talking about the curved surface area. The curved surface area will be what? See, for one circle, what is the area? For the one circle, what is the area? So for the one circle, we are having the area pi r square. We are having the area pi r square. So in this case, we are going to have what? In this case, we are having the not curved surface area. We will not be considering the area basically. What are we going to consider? If we talk about the basic circle over here, this circle, the bottom one. The bottom one I want simply the outer periphery of it. Outer periphery. If you think about a bangle, so the bangle entire boundary, what is the length of that boundary? So it will be the circumference of the circle. So it is 2 pi r. So 2 pi r, and along with that we are having multiple of those. So basically a compilation of multiple circles. So how many circles, sir? If I add like this, 1, 2, 3, 4 like this and go up till h. So how many? It will be 2 pi r h. And that is exactly what the curved surface area of a cylinder is. That is for the cylinder. Now, if I have to come up with a total surface area, sir, how it is different from the curved one? In this case, when I talk about the example of bangle, or if I talk about the example of tire, let's say I'm covering up the top body, the top surface of it and the bottom surface of it. What kind of a surface would be? Circle in shape. So, how many surfaces are appearing? 2 surfaces. So whatever the curved surface area is, if I add 2 pi r square, we'll be coming up with the total surface area. And the formula over here will be simple. If you do the calculation over here, you'll come up with 2 pi r h plus r. Now many of you would be thinking, sir, how this will be appearing this? Something you would be doing, right? So I'm not going to write each and everything for you. Something either you remember it or either you put some effort from your own end so that you get the clarity that this is the formula would be coming up. Next thing, we have talked about the surface areas. Now we are entering to the phase of volume. Now for the volume, as I had already started, inside the bangle, how much portion would be there? Inside the bangle, how much portion would be there? So over here, if I have to simply indicate, this is the portion. Now, this is the area of the circle we are talking about, pi r square. And like this, we have accumulated multiple, again h. So, over here it comes to be simply pi r square h. This is the volume coming up. Now, what's the point? I could have written the formula straightforward, but I am making the sense out of this formula so that you can understand that over here, you don't need to mug it up. When the chapter is having multiple formula, the student is having this assumption, it's a totally formula thing and you don't have to apply your mind. Each and every place formula are coming from some understanding, and if you get that understanding, you never will need to mug it up. So please try to understand where the formula is coming up. So I have given that clue to you, that perspective from which you can think about. So this is about the cylinder. The next body, I believe you know what are we going to talk about. The body we are going to talk about is cone. So same thing, curved surface area and then total surface area. For that, first of all, we need to draw the body cone. We are having a triangular structure with a circular body at the bottom. Now, this is a cone, and the best example of it would be birthday cap, which you can think of. Now, the birthday cap is hollow from inside, so you are not getting a clue about the bottom surface. So you can think about a solid kind of a thing which is having the base as well. Now, in this case, the base would be what? A circle in shape. Sorry. So sorry for that sneezing and coughing part. I'm like little under the weather, so I believe you can pardon me for that. So now in this case, we are having a body which is having a circle surface at the bottom, and the above part will be entire what? Curved thing. It will be a curved thing. So best example of it can be when you have gone to a traffic place, over there will be multiple conical thing put up. It will be something like VLC player. I don't know whether you guys know of this generation, know about the VLC player or not. Kind of a cone is there with the orange stripes, orange and white stripe. So VLC player is the best example of cone to understand. In this case, the curved surface area represents this portion. This curved part. So this curved part is very simple to understand. If I tell you the formula, it is pi RL. But the next question is, what is this L, sir? We haven't talked about L. We have already talked about L in the previous grade. I am just doing the revision for you. So to tell you, L is the slant height. This height. And how it is different from the height? When we say about the height, we are talking about the perpendicular height. So height from the top to the base. This is the height which we are talking about. This is the perpendicular height. So H is different, L is different. Is there a relation between those? Yes, there is a relation. If you observe the 2D figure of it, you will observe a right angle triangle. And right angle triangle is always involving some Pythagoras theorem. So for that, L square is equals to H square plus R square. And R is this part of the base. That's it. That's the relation of converting height and radius into L, or the slant height or radius into the perpendicular height. Whatever two things are given, you can get the third one, and that is what they are going to give you in the problem statement. Over here in the curved part, if you add the bottom surface, so as I mentioned, CSA plus, only one surface is there, so only pi r square. So we'll come up with a formula, which will be pi r L plus r, the formula for the total surface area. So things are again very easy to understand. Final thing will be the volume in this case, and the volume will be 1/3 of what cylinder is. 1/3 of whatever the volume of the cylinder is, which is pi r square h. So here we have the three important formulas. For the case of cone, I have given you the examples of cone, I have given you the understanding of the difference between L and H and everything. So moving on to the next body, which will be entirely curved in the nature, and that body is basically sphere, with which I started. I believe many of you would be sports fanatic, and I might be wrong in saying fanatic. At least you would be lover of some sport. It might be cricket, it might be basketball, it might be hockey, it might be football, it might be golf. Game like golf can be interesting for many of you if you understand it, and for the rest of people, tennis, or I would not say badminton, because badminton is an exception where we don't have the ball. So you can understand what kind of a sport would be this. Over here, we are talking about a ball. So this is a solid ball, and solid ball is basically a 3D caricature of what? A circle, right? So over here, this is a sphere. Sphere is a solid thing. It is having the outer periphery. Inside this, it might be hollow. It might be having something. Over here, so we are going to talk about all those things. So first thing coming up over here, the total surface area. And that over here is 4 pi r square. Someone might ask, sir, you didn't start it with the curved part. Why? The reason is there's no difference at all. The curved and the total will not have any difference, because if you observe that particular ball, whatever ball you have, it might be a cricket ball, it might be a football, it might be a basketball. So all the balls are having entire curved portion. There is no straight surface like that, like we had in the case of cylinder or in the case of cone. So if no surface is there, so there will be no difference between the total and the curved one. So total, you can put up a slash and assume it to be the curved one if you want, if you like it, if you want to write the formula for curved as well. So this is a formula, a single formula for the area. Good thing for us. And the next thing appearing over here would be volume. So volume of this would be what? 4/3 pi r cube. The only difference over here is pi r cube. R cube. Don't make a mistake. This is a common thing which many of the students does, that rather than putting r square cube, they put up square over there. This was about the sphere, but sphere, if it is not having one formula, it will be having two more formulas. How so? Now from the sphere, if I put up a cut like this, let's say Earth was there and some like extraterrestrial forces come up. We are talking about the aliens. So some alien with some superpowers were there, and they just cut the entire Earth into two parts. Two balls appearing like this. So they are not the entire ball. They are the half portion of it. And what do we call them? We call them as hemisphere. Hemisphere, half of the sphere. So it is hemisphere. In this case, the curved portion, will be 2 pi r square. Why, sir? Because it was earlier 4, so entirely half is the part we are interested in. This is the half we are interested in. So over here, half of 4 will be 2 pi r square. But when we talk about the total surface area, things will be quite different. Why, sir? Because now if you observe, by that cut we have made over, we are having a surface which is circular in shape. So extra pi r square is appearing over there. So if it was 2 pi r square over here, we are adding one more pi r square and will be appearing as 3 pi r square. This was about the two extra formulas which we have got from the sphere part. You are very happy that it is having only 2, not 3. So here we have more of those. So one more thing is still left over here, which is the volume. So volume also, let me write it over here. It will be exact half of what we had in the case of sphere. So 4 over here will be 2/3 pi r cube. Cube again, don't miss on this part, it is cube. And wherever we are having cube, so make sure that units, whatever you are writing, should be centimeter cube, meter cube, kilometer cube. And what kind of a body can have a size of kilometer cube? You can think of very big bodies we are talking about over here. And for any case, we are talking about the area, it will be simply meter square. So that is all the formulas, I believe. In the terms of revision, I have done the revision for grade 9 and 10 at the same time, because as I mentioned, in grade 10 there is nothing new at all. Everything remains the same. So now if nothing is different, so what are we going to talk about now from here onwards? I'll be giving you an understanding, a hint by few problems, how things will be different in this particular case. To start with, I'll not talk about the question first. This is the entire summary of what I have talked till now. So if you haven't noted till now, I don't believe we'll be noting anyhow. So it's my responsibility to show you over here. So I have shown it over here if you want. So now also you can note it down. Just pause the video and note it down. Otherwise, previously we have also talked about all those things. So in case I have written something wrong, so please correct yourself. This would be the correct list. Obviously, computerized things don't commit any error. Human can. Okay, so moving on from here and talking about what we have in grade 10. So what we have in grade 10, we are going to talk about 3D figures, and when we say 3D figure, the real figures we are talking about. So what are these real, sir? So I believe many of you would have already had a conical ice cream. So what is ice cream exactly? Ice cream cone which we think about. So it's a cone like this. It's a cone like this, but it's not the simple cone. On the cone itself, if this is the cone, we are having some kind of ice cream. So let's say you are having strawberry. So this is the strawberry we are having. So over here, this is the conical part, and above it we are having a hemisphere. So we are having two bodies at the same time, and that is what we are going to talk about. We are going to talk about the combination of solids. Combination of solids. If you want to think about more example, let's talk about another toy. We are having a hemisphere over here. We are having a hemisphere. Now we have reversed entirely and we have put up a cone above it. This is a common toy which we come across. Common toy. People play with this. They basically disturb the position, but since it is curved, it will try to come back to the same position. So basic physics is involved over there. If you are interested, you can think about this as well at the same time. So, sir, why are you talking about things which are very childish in nature? No, these are not childish in nature. You can play with these, as well as if you want to talk about something mature. So, I have a pen stand. So, pen stand basically what do we have in the case of pen stand? So, pen stand basically, let's say if this is a cuboidal body, and this is the front face of it. When I say front face, so now this will be appearing only as the front face, and there is a solid body behind it. Now in this case, when we talk about a pen stand, so pen, basically this is also a pen. So I believe you would be able to see, if the camera is so good, it will be able to show you the conical part over here, and this conical part goes like this inside that particular structure which is called as the pen stand. So what is going to happen over here? You will be going to have few depression which will be conical in shape like this. So it depends how many of the pan it can hold. So accordingly, it will be having those structures. So like this. Now this is a combination of solid. This is a combination of solid. How? We were having a cuboid, and from the cuboid we have taken out some conical part of it, and now it's a solid body made up of two combination. One being the cuboid, another being the cone. You can think of many more. If I put up a cylinder like this is a cylindrical tank. And inside the cylindrical tank, what do we have? Inside the cylindrical tank, let's say we have put up a conical structure entirely. So we have dropped something, and that is a big conical structure. So it will be appearing like this. So now what is happening? We are having a solid body, or let's say we have done the excavation out of it. We have digged out whatever the solid cylinder would be having. From the solid cylinder, we have taken out whatever the material it is made up of, and we have come up with this kind of a structure. In this kind of a structure, this part would be the solid, and rest of the part would be the hollow part. So if I have to show you, indicate it. To be honest, as a teacher, there is a limitation to do the representation on the board. So it's all about your imagination, how involved you are around yourself, looking around the room you're sitting in, looking around the water bottle you're having, looking around the pen or the pen stand or whatever multiple things you might come across in your room. So these are the figures which we'll be dealing with in this particular session, and almost more than half of the session would have already been gone, because now in this chapter I told you there's the second part which is the bad part, which is the calculation, which is the mundane thing, and I'm not going to be involved over there because I cannot teach you calculation because that part is already gone when you are learning in grade 4th, 5th, 6th, 7th up till that stage. Now no one will be teaching calculation. That is something you have to own yourself. So what is the rest of the thing which we'll be talking about? The basic problems is what we can talk about. Basic problems. So over here, if you read the problem, it says a cubical block of side 7 centimeter is surmounted by a hemisphere. Okay. So let's first talk about, we are having a cubical structure. So let's draw a cubical structure. I hope I am good at drawing so that I can help you out with the representation. Otherwise, you will be cursing me. So how I'm going to understand with this? This is a cube. This is a cube. I hope this appears to be the prototype of cube, and this is what cube looks like. Now, the cubical block of side 7 centimeter is surmounted by a hemisphere. Surmounted by a hemisphere. It is not surmounted on a hemisphere. A hemisphere has been put above it. So please read each and every word carefully. And over here, some understanding of English language is going to play a important role. So please read it multiple times if you believe that you are not good at comprehension. So this is the place where you can start learning comprehension, and in the English examination also it will be helping you out. So having a hemisphere above it. I don't know whether how good this representation is, but this is something like this. We are having a cubical box, and above this we have put up a basically half ball, which is a hemisphere. Now this is the first statement of the problem. Rest of the statement is what you need to understand and calculate. What is the greatest diameter of the hemisphere that we can have basically. So over here, first thing, the greatest hemisphere what we can have is the one which will be having the diameter equal to the side length. From this point to this point, this will be the diameter, and this should be exactly equal to the side length of the cube. Agree on this part? If it is exactly equal to the side length of the cube, in that case, we can say that is the greatest hemisphere which we can surmount. Otherwise, it will be further big, and that is not we are talking about. We are surmounting a hemisphere which will exactly fit in on that particular cube. So one thing is that the side of the cube is equal to the diameter of the hemisphere. So this much part will be done. Find the surface area of the solid. Now this is the part which examiner is more interested in, because till this point of time everything was theoretical. Now when we want to calculate the total surface area of the solid body, understand one thing. TSA of the body. The body is made up of, a cube. It is made up of a cube. So first of all, let's take up the entire surface area of the cube. Entire surface of the cube is the total surface area. Okay. Now, what happened over here? Now, on the top surface, we have put up a hemisphere. Now, when you put up the hemisphere, that entire portion of the hemisphere, this thing, will be exactly overlapping the surface of your cube. When it is exactly overlapping that particular space, that particular surface, would you consider it to be a surface area? Because it has been already included in the structure. Like this, if I say that there are multiple faces inside the cube, no sir, they are not, because they are inside it. So we cannot consider something which is appearing on the outside is what we are going to consider. So over here there is a overlapping, and that extra surface is gone now. So what is left? We are left with some part of it which would be on the portions of it like this. This portion, the portion on the back side, the portion over here, and the portion over here. How would we bring that up? If we know what is the surface area, of that particular surface of the hemisphere, that is basically circular in shape. If we remove from the total surface area of that of the top surface of the cube, we'll get to know the rest of the portion. So from this total surface of the cube, I'm going to subtract the surface area of the base of hemisphere. So you might come up, sir, we haven't learned the formula for this. We have learned everything, sir. The base of the hemisphere will be circular in shape, and that is pi r square. If you know the radius of the hemisphere, you know this part as well. Okay, are we done? No, sir. Still something left. What is left? Over here, we have kept a hemisphere. Don't you think so? This will also appear as a new surface now. This will be a new surface, or I should put up a new color over here to give you a better representation. This will be your surface. The curved entire curved portion. So we have to take it into our consideration. How we are going to take in consideration? By adding it up plus the CSA of hemisphere. The CSA of the hemisphere is what we are going to consider, and that will give you the total surface of the solid body. Now you would say, sir, the question is complete. No, the question will never be complete if you are not involving any calculation. For the calculation, they have given you few things. They have given you the side length as 7 centimeter. So if you observe over here, 7 centimeter is this length, and same will be the diameter. Same will be the diameter of the hemisphere, 7 centimeter. From that, you can calculate the radius because that will be half of it, 7 by 2 centimeter. And over here, A is also 7, the length of the cubical body. So whatever is required in the formula, everything is given. You have to just apply the formula. I have spent a lot of time talking about the formula, so I'll not be talking about the formula once again and putting the values for you. This is the thing you have to do from your end. This was the theoretical part which I have to explain and make you visualize. So I hope I have done that part right. If you are understanding the visualization, half of the problem, I would say 3/4 of the problem is done. Rest the portion does not involve any kind of application. It is simple application of the formula which you have to do, just put down the values. So take a good look at this question, then we move forward to the next one. Anyhow, you can take a good look by just pausing the video also. So moving on to the next problem over here. A hemispherical depression is cut from one face of the cubical wooden block such that the diameter of the diameter L, this is representing L, of the hemisphere is equal to the age of the cube. This question, if you read carefully, if you comprehend well, this is what I told you. You can learn English comprehension from here. This is the exact opposite of what we have done in the previous question. So over there, a hemisphere was mounted on a cubical body. Over here, a hemisphere has been cut out of a cubical body. So a depression is created inside a cubical body. How it will look like? Something of this sort. We are having a cube. Now in this cube we have taken out a hemisphere. A hemisphere depression is cut off from one face. Let's say from this top face over where we put the hemisphere. This time we are cutting it out. Wooden block such that the diameter L of the hemisphere is equal to the age of the cube. So obviously over here the diameter will be equal to the age of the cube. So over here when you cut it out, it will be something like this. I don't know whether you are able to visualize this much part or not. So understand one thing. If the length of the cube is equal to the diameter of the hemisphere. So on the surface, this entire part will be same. This entire part will be gone. And inside also, the height or which you would, okay, what happened over here? Okay, yeah, so on the surface the diameter is equal, and if we talk about inside the cube, the body, the bottom point of that particular this solid body, which was not solid body exactly over here, this hemisphere will be touching the bottom of the cube. Why it will be touching? Because L is what we are having over here, and same is the diameter as well. Diameter of this body is equal to L. This is clearly mentioned over here. Diameter of the hemisphere is equal to the age of the cube. So over here, this will be touching to the bottommost point of that cube. So this is how you have to understand the figure, by reading question very carefully and reading it multiple times. So now when you talk about the remaining surface area, remaining surface area. So first of all, what we had a cube. So total surface area of the cube as usual. After the total surface area, sir, after the total surface area, now understand, we have again gone with that extra surface area. So this much portion on the corners would be remaining. How we'll get to know how much portion? By subtracting the surface area, of that base of the hemisphere. So we have to do some subtraction. Base of the hemisphere will be subtracted from the total surface area of the cube. And so that is all. No, again, this time when you put it on the top, so it was that particular curved portion that would be part of the total body. And when you have cut it out, create a depression, in that case also, you have to consider it. You have to consider the curved part of that particular depression. This curved part would be considered in that case as well. So on the inside also we are having that surface area of the curved portion. So it will be again added, the CSA of the hemisphere. So this thing is what you have to do, and the good thing about this question is no calculation would be involved. Why no calculation will be involved? Because the diameter is equal to the L, and they are talking in this term, they haven't given a numerical value. So I hope we can put down the value in terms of D and in terms of L. Ultimately, there is a relation of diameter and the length directly given to you. So we'll come with a simple answer over here. So the problem is still to be solved for you. Definitely something should be left for you to solve, and this is the important part you have to think about. So take a good look about the problem. We can move ahead to the next problem. This is the next body which I'm going to talk about. It seems like a capsule. I hope many of you have seen the capsule. Capsule looks like this, right? So capsule is again a combination of multiple things. Multiple things when I say. So first thing is over here, a cylinder. This is a cylinder. Then we are having a hemisphere on the other one end of it. This is the hemisphere. Let me make it hemisphere in a manner that seems to be perfect. Now it seems to be perfect. And from the other end also we are having a hemisphere. Alright, so that is what making up a capsule. So important part of this question was to understand the combination. Now if you talk about the surface area, find the surface area. So things will be very simple. The total surface area in this case will be what? The curved surface area of the cylinder, because we are taking only the curved portion. That means this portion I am talking about. Right? So we'll be taking up the curved surface area of cylinder. And only this. Why not the top and the bottom part? Because that has been included over here. They have been joined, so it will not appear on the outside. It is the part of inside structure, so we will not be considering that. What we'll be considering? We'll be considering the curved portion of the hemisphere over here. And since two hemispheres, so what? Plus 2 into the CSA of hemisphere. Ultimately, if you know the formula, it is same as the sphere's total surface area. And that is the formula you have to apply. The dimensions have been given. The interesting part about this problem, if you are going to solve, I don't know whether you are going to do or not. If you are going to do, the 14 is the entire length of this capsule. So how would we get to know the height of the cylinder? So height of the cylinder can be easily known, because if this is 14, I know one dimension, which is this. This is 5. If this is 5, so this will also be 5. This will be what? This will be not exactly 5, this will be 5 by 2. This is interesting to catch over here, because the total diameter is 5, so radius will be what? Half of 5. So same will be happening over here. This will also be 5 by 2. So if we subtract from 14, 5 by 2, 5 by 2, that is basically same as 5. So we'll be coming up with the length, or I would say the height of the cylinder, which will be in this case simply 9. Now I believe we'll be having all the dimensions which are required to do the calculation. So that was the interesting one. And like this, we are going to have multiple. We have talked about surface area. Let's talk about the volume as well. And so that you get an understanding how to go about. Because like this, I can create multiple kinds of problem, and that are real life problem, because capsule is one of the case which is a real life thing, right? So let's look for a case where we are having a volume of a body. So taking up with the volume, the first question over here in terms of volume part. A solid is in the shape of the cone standing on the hemisphere. Okay, so I have already given the example which seems like to be a toy. This is a hemisphere, and above this hemisphere we are going to have a cone like this. Okay, so this is the example which we had taken in the very starting, and this is what we are talking. A solid is in the shape of the cone standing on the hemisphere with both their radii being equal. Obviously, this radii would be equal. This is the radii of both the cone as well as the hemisphere. Equal to 1 centimeter, and the height of the cone is equal to its radius. So whatever be the radius, if this is the radius, the height of the cone is also equal to the radius. This is also equal to the radius. So h is equals to r over here. H is equals to r over here. This is one thing. We need to find the volume of the solid. So volume would be what? To be very honest, when we talk about the volume of a solid is comparatively easy than the surface area. Why, sir? Because volume is basically the space occupied by that particular body, and for that you don't need to think what is inside, what is outside, and so on. In the case of surface area, you need to understand that which surface have been gone inside the body and will not appear on the outside. So, will not be the part of the total surface of the body. In this case, that will not be the case. In this case, that will not be the case. Why? Because the volume of the solid, the volume of this hemisphere, the volume of this cone, and that will be done for the volume of the solid body. So, this will be volume of hemisphere plus the volume of cone. If you are too tired up, sir, each and every question you are leaving us to us, so I'll be solving this for you. It is much more simple because no calculation is involved over here. It will be what? Hemisphere is what? Hemisphere is basically 2 by 3 pi r cube, and volume of the cone is 1 upon 3 pi r. Over here, what is that? Pi r square. Agree on this part? Pi r square. Now, we have been told pi r square, not only pi r square h it is, right? Pi r square h, because pi r square h is the volume of the cylinder, and for the cone it is 1/3 of it. Please remember the formula, they are very, very important. Now, in this case, h is equals to r, and do we have any understanding about it? Both being equal to 1 centimeter, so this is being equals to 1. If I put the value of r as 1, h is 1, r over here is 1, what are we left with? Leave the r part, because wherever we have the multiplication of 1, it will remain as it is. We are left with 2 by 3 pi, 1 by 3 pi. So I can do the addition by taking pi common, which is 2 by 3 plus 1 by 3, which I do understand over here. Is 3 by 3, and 3 by 3 is what? 1. So we are left with what? Is it in centimeter? Yes, sir, it is in centimeter, so centimeter cube. Here we have done it. So don't complain later on that I haven't done the calculation part. I have done the calculation part over here, and this is how it's done. So you can take a clue from here and you can understand the problem. By this problem, you will get a clarity that volume is comparatively easier to go forward with, and yeah, they are much more simpler when we talk about calculation in comparison to the surface area. So one more thing I would like to say, like this I can go on forever by taking multiple real life solid bodies, which will be combination of multiple things at the same time. So I'll not be going on and on. I'll take one more problem which will be an interesting one, and then I'll be leaving you to do the rest of the revision part on your own. And this is a problem which I'll like to end with. What's so special about this problem, sir? Along with the volume, they have added one more concept. Many of you like sweet, so let's end on a sweet note. We are having a gulab jamun, and gulab jamun is in the same is in the shape which I would be liking to draw over here, because many of you would be confused. Why are they of this shape? Now, there might be a confusion, sir. Gulab jamun are generally in the spherical shape. No, they can be of this shape also. If you haven't eaten, you need to visit the nearest sweet shop. They are having the kala jamun part, they are having the normal jamun, and they are having this kind of a jamun as well. This jamun is what? This is basically a cylinder, along with we are having a hemisphere. So again, clearly mentioned like a cylinder with two hemispherical ends, just like a capsule. The capsule was not good in taste, but this will be sweet in taste and everyone will be, voila, what good thing we are having over here. So in this case again, as I mentioned, calculating the volume part will not be difficult. Volume part is very simple because volume of cylinder plus the volume of the hemisphere. But hemisphere, since we have involved two, this is the one, this is the second one. So we can multiply with 2. We can multiply this 2, or I can say simply make up a sphere out of it. We can calculate the volume, but they are not interested in the volume, they are interested in how much syrup would be found in 45 gulab jamun. For one gulab jamun, you can calculate the volume. Similarly, you can calculate the volume, total volume, which will be 45 into volume of 1. And this all would be happening if you have read the question carefully. Because each and every time I was reading the question, in this case I haven't read it because I know the question. I believe you would have read the question by now. Now, they are not interested in the volume of 45 gulab jamun. They are interested in what? They are interested in the part of the sugar syrup. And how would we know the content of sugar syrup? A gulab jamun contains sugar syrup up to about 30% of its volume. So let's say if we are having 100 meter cube or 100 centimeter, 100 meter cube would have been a huge thing. 100 centimeter cube as the total volume. So 30%, 30 centimeter cube is what the syrup is there. So the volume, total volume coming. So the syrup is 30% of the total volume. I believe if you are doing so much calculation, doing the calculation of the percentage will not be a task. That is the easiest part among all. So this will be the ultimate thing which will give you the final answer. If you are leaving the answer up till this stage, incomplete. If you are leaving up till this stage, incomplete. If you come to this stage, then the question will be complete. And by this, you would have realized this is a big problem. And over here, you'll be involved with calculation, you'll be involved with concept, you'll be involved with some kind of a percentage as well. So more of the concepts involved in the problem, more holistic the problem is, and that is what examiner likes, so that they can test you for the entire mathematics, not a single isolated concept. No one likes a single isolated concept because they want to see each and every side of your personality, right? So the third dimension is there or not, or multiple dimensions are there or not. So in this manner, I like to wrap this chapter up for you. And as I mentioned, the formulas play a pivotal role over here. If you are clear about the formulas, you will be very well versed with each and everything in this chapter. And as I mentioned, nothing goes out of the formula. Even this kind of a question which seems to be complex, this is nothing but the application of the formula. That's it. 30% is what, at least this much sense you would be making out of the question, right? So comprehension, applying the formula, the final thing, doing the calculation in 2 and 3 aspect, things would be done. So enough of the lecture given, and I'd like to leave you over here. That is all from my end. Enjoy your time. Make sure that you're doing the calculation right. We'll meet in the next session where we'll be discussing the next chapter, I believe. That will be statistic. So till then, have a great time. Another chapter based on the formula is coming for you, waiting for you. Have a great time. Enjoy yourself. Bye everyone.